It's good to be with you. Welcome to Class Outside. Today, we're going to learn how to bundle our web application using a tool called Webpack. Bundling combines all of the code necessary for the web browser in one place. Classes and dependencies not used by your application will be removed. This removes the security vulnerabilities of serving the entire Node modules folder to the web. This process may also improve performance by breaking up code into chunks that can be loaded on demand. What do we need? We need a local server setup. I will be demonstrating with a Node.js and Express.js setup. If you'd like more details on this, I've linked another video in the description. We'll also need an integrated development environment or an IDE. I will be using Visual Studio Code. We'll need a package manager for installing JavaScript libraries. I will be using Node Package Manager or NPM. We will also need Webpack and a variety of dependencies installable through our package manager. I will be demonstrating using this project. It uses an imported library called 3.js to create a spinning 3D ring in the browser. The starting and final code for this project will be available on GitHub, linked down in the description. First, we must install Webpack and the variety of dependencies we will need. Open your project in your development environment. Now, open a new terminal window. Make sure the terminal is pointed at the root directory of your project. Type the following: npm install --save -dev webpack webpack-cli babel-loader babel/core babel/preset-env html-loader html-webpack-plugin. What does this mean? Well, --save dev adds an entry to the dev dependencies section of the package.json, a file which keeps track of the installed libraries and dependencies for your project. This basically tells your application, what I'm downloading is for development. Make sure it doesn't go to production. Webpack downloads the Webpack bundler we discussed earlier. To use this bundler, we require webpack-cli or command line interface, which allows us to access Webpack via the command line or terminal. Babel-loader is actually a Webpack-specific loader. This lets you use Babel, a transpiler that takes your JavaScript files and converts their syntax for compatibility with previous versions of JavaScript. Transpilers are like compilers. Compilers take your programming language and convert it to code that can be run by the machine. Transpilers change one language into a different language or a different version or dialect of the same language. HTML loader has a similar role. It can convert HTML files into a string object, which then helps Webpack edit and modify the file during the bundling process. Babel preset-env is also included. This package is necessary to support new JavaScript features in older JavaScript versions that go beyond syntax changes. This is accomplished through something called polyfills. Basically, polyfills aren't new features translated to older JavaScript code. They are essentially new features rewritten for the older JavaScript versions. Preset-env is also necessary to tell babel-loader what environments to transpile to. By default, preset-env targets the latest 2 versions of all major browsers, and all browsers with over 0.5% market share. Performance is better when you define specific supported browsers, though the default will be fine for our demonstration. Babel core is Babel. This includes the code necessary for Babel to transform the code. The HTML Webpack plugin provides an added feature to Webpack, which lets Webpack build our web page's starting file, often named index.html. With Webpack and our other dependencies installed, we can create the webpack-config file. At the root of your project, create a new file and name it webpack.config.js. This file is how we tell Webpack how we want our project to be bundled. I'll briefly go through what each part of this file is doing. We first import HTML Webpack plugin and path. Path helps us tell Webpack how to locate different folders. Module.exports is a statement that we are exporting a configuration object for Webpack. Entry is the entry point for our application. This has to be a JavaScript file. Webpack can handle one or more distinct entry points. Perhaps I'll have another video on this someday. For this demo, I set main.js as the entry point. That is the file that creates a rotating ring with 3.js. Output defines what folder the bundled code will be placed in. Here, it states that the bundled files will be placed in a directory called dist, short for distribution, with the name bundle.js. The source map dev tool is unnecessary, though helpful for troubleshooting. It creates a map from the original code to the code generated by the bundler. Modules lets us define rules as to what Webpack should use to transform or transpile our code. Rules often have the test and use fields. The test field accepts something called a registry expression. Basically, the funky slashes and characters mean something. This expression means test if the file you're looking at ends in .html. If it does, this rule should apply. The use field accepts a loader or a library that can transpile the files that are caught in the test. For HTML files, we use the HTML loader to convert them into strings. We see a very similar pattern in the other rule. Each file ending in .js for JavaScript will be caught by the rule. Here, the use field takes an object of multiple properties. The loader is set to the babel-loader. Babel-loader alone cannot transpile code if it doesn't know what to transpile for. It's like a translator who knows 50 languages and is asked to translate a film and doesn't know what language to translate for. Without telling it what languages, it might output a translation that is not useful for whoever requested it. In the options field, we name a preset, Babel preset env, which provides Babel a list of what targets to translate for. By default, it supports the last two versions of major browsers and more. However, you may also request specific browser targets within Babel preset env. For this video, we'll stick with the defaults. In the HTML Webpack plugin, we set up where to find a template to use when generating our index.html. We can see this is in the template field. In this demonstration, the template will be found in the source folder. We can also set up some characteristics for the output index.html file. Here, we set minify as true. This reduces the size of the generated file by removing white space, redundant characters, and more. Now that Webpack is configured to generate a new initial HTML for us, let's update our server file to serve this HTML instead. Instead of providing access to the source folder, we will need to provide access to the folder with the generated HTML file. The generated file will be sent to the same directory listed in the output field. In this demo, that is the dist folder. The generated file will also have the same name as the template file. Therefore, it will be named index.html. So, in our server configuration, we no longer need to serve our src directory. We need to serve the dist directory. Make sure the app.get field's response has the correct directory and file name set up. While we are in the server configuration, we can also remove the statements serving our node_modules folder. Webpack will bundle all the necessary files to serve from node modules into our bundle.js and leave out the unnecessary ones. The last file to update is our index.html. Now that it is acting as a template, we can remove some of the setup it had before. For one, we can remove the import mapping. Webpack will take care of this. The imports will be identified during the bundling. When Webpack has access to all the files, before the server software gets involved and begins restricting access to directories. We will also want to remove the script tag for our main.js page. The generated file will perform an operation similar to this for the script we defined in the entry section of our Webpack configuration. With all of those files set up, we can now run Webpack. This will scan our project, apply the rules we set up, translate JavaScript and HTML files, and then output new bundled files in the dist folder, ready to be sent to the browser. To do this, open a terminal window and navigate to the root of the project. Run the webpack command with the configure option and set the configuration to the webpack-configure.js file we set up. With npm, the command would look like npx webpack-config.webpack.configure.js. npx is a Node package manager feature to run some commands from packages. Other package managers likely have their own alternative version of npx. Webpack command comes from the webpack-cli we installed at the beginning. We use the --config option to define our configuration file, which is webpack-configure.js. This should take a short time. If any errors do pop up, they will be available in the terminal window for review. With the current setup, every modification or new file will require Webpack to be run. I've linked another video in the description that walks through setting things up so that Webpack runs and your local server restarts automatically after any development changes. Once all the errors are resolved, we should be able to run our server. Use cd to change to the directory of your server file. In this demo, that is the source folder. Then start your server. To do so, I will use node app.js. And look at that! Together, we have bundled our web application using Webpack. Please let me know down in the comments what you thought of this video. Have a great day, and thank you for attending class outside.